Hello everyone and welcome to the Easy Chemistry channel. We are going to continue with our experimental chemistry. This is the second subtopic of the experimental chemistry and hopefully the final one as well. So today we are going to learn how to deliver different sort of gases, and for that we need to know the list of gases that are present in our syllabus. And by the way, these are the gases that we are going to be studying in the O-levels syllabus. So there is very precise and very to the point information present in this table. You can see the name of the gas, the formula, the MR, which is the mass of the gas, and this is the density of air, which is 29 or 30. And this tells you that it is much less dense than air, and then there it tells you the solubility. You can ignore this. Okay, now this is a very precise table and it gives you a precise information. So what you need to look for right now, the first thing is the solubility of some of these gases is very high. So some of these gases are extremely soluble, they're very high. We need to find them out and circle them. So the first one is this gas. This is ammonia. Okay, so ammonia gas is extremely soluble. All right, and then we go towards this sulfur dioxide gas, and sulfur dioxide gas is again extremely soluble. And then finally HCl gas, which is again extremely soluble. So these gases are very soluble in water. So this is the information that we are going to be using in this next step. Okay, so now since we all know that, now we are going to move towards the next step. The next step is understanding the different methods of delivery of gases. So this is method number 1. This I'll call method 1, and this I'll call method 2 and method 3. Method 1 is downward delivery method. Method 2 is upward delivery method. As you can see, this tube is delivering the gas upward, and this is delivering it downwards, and this tube is, by the way, delivering it upwards. And this is the water delivery method. You can see there is water. Okay, now, so first thing first, this water delivery method, by the way, the third one, this is the best gas delivery method. So whenever a reaction takes place somewhere over here and the gas is pushed out, so this gas goes on into this tube and is released over here. So initially this whole measuring cylinder is filled up to the top. Okay, this is entirely covered with, filled with water. So when our gas is finally released, because gas is less dense than water, so this gas is going to rise up in the form of bubbles and be collected over here. And whatever volume of that gas is collected, you can easily note that volume in the measuring cylinder by looking at the reading. Okay, this is the best method of delivering any gas. But there is one big shortcoming which we discussed just earlier, and it is that shortcoming is in these three gases. Number 1, ammonia. Number 2, sulfur dioxide. Number 3, HCl. So these three gases, because they are extremely soluble in water, so even if you use this method for these three gases, you are ultimately going to get these three gases dissolved before they reach up to the top. So ammonia, this is the formula of ammonia, by the way, and NO2 and HCl, these three gases cannot be delivered via this method. Okay, so this is how we are going to identify if or whether we can use water delivery method for a specific gas or not. Now moving to the next stage. So we are left with 2 more delivery methods. Now before we go on to explain this, we need to understand one more thing, and that is the average density of water, or in other words H2O. So the average density of water is around 29 or sometimes 30. Okay, so this is the average density of water, 29. Okay, now we need to know which gas we are trying to deliver. Let's suppose the gas that we are trying to deliver is chlorine gas. Chlorine gas has a formula of Cl2, and its total mass is 35.5, by the way, plus 35.5, because there are two chlorine atoms. So one atom has a mass of 35.5, the other atom obviously has the same mass of 35.5. So this gives us a number of 71. So chlorine gas has a mass of 71, but as we have just discussed that only that those gases which has a mass greater than 30, those gases are heavy, or in other words denser than air. So obviously those gases, whenever they are released into something, they are going to go and be collected downwards over here. They are not going to rise up. Why? Because they are very heavy. So chlorine gas is one of those gases which is a very heavy gas. So if 30 is the density of air, it's well above 30. Okay, more than half above 30. So we can use this method for collecting chlorine gas. All right. Secondly, we also need to know one more thing, and that is the upward delivery method. So upward delivery method can be used for literally any gas. Okay, we can use it for any gas that is lighter than air. Okay, lighter than air. All right, so let's suppose we have this ammonia. Ammonia has a mass of 17. Now because ammonia is soluble in water, so it cannot be this water delivery method cannot be used for it, and it has a mass of 17, which is less than 30. Okay, so it is less than 30, so we can use the upward delivery method for collection of ammonia. So whenever ammonia comes in through this pipe, it is going to stay up, it is not going to come down, because it is lighter than air, just like helium is. When you fill a balloon of helium, so the helium is always going to rise up, and this is why helium balloons fly up. All right, and this is how we collect all these gases, and these are the main three methods of collection of gases. So the only piece of information that you actually need to know is the solubility of gases. Okay, and if you don't know what the relative mass of a gas is, what MR is, you don't need to worry about that, because we are going to discuss this in a great detail, and this is not going to be a problem. So for now, you just need to know that because ammonia and some other gases, they have low mass, so you can just ensure that if the gas is soluble in water, then you cannot use this water delivery method. So yeah, so that's it, and take care, and let's meet in the next lecture. Goodbye.